Hey guys, welcome back to the channel. So today we would be attending this due to contest which is Codeforces round 1048. So let's get started with the contest. Okay. Minimum number of operations required to make it equal to B. This is always possible. Okay. So if one of the element is 1, if one element is 1 and the other element is any element other than 1, then only one operation is required. Okay, and if both the elements are equal, then always zero operations are required because they are already equal. Okay. Okay, what about this 10 and 3? Okay, so the LCM of them, what if we find the LCM of them? What if I have 30, like let's say I'm selecting X as 30, then how many operations will be required? Okay, so 2 operations are required. Okay, so let's say I have two numbers. If they are equal, then basically our answer is 0. Let's start writing our observations. Let's code them. Okay, so let's take input as 2 elements. A equal to B, then simply what we have is, say these are the operations, and it would be simply if A is equal to 1 or B equal to 1, if any of them is 1 and the other one is anything apart from 1, in this case the operations would be, sorry, here it would be 0 and here it would be 1. Okay, now the operation is something apart. Now the values are not equal and also they are not 1. Okay, so if an element is multiple of the other, then I can just provide its value, like if a mod of p equal to 0, that is the first element is multiple of other, then let's make the first element to the other element, so it would be a by b. By b, let's say I have something as 9 and 3, so to make all the elements equal, 3 3 is 9, I can do this. Okay, else if p mod of a equal to 0. If this is the case, then it would be simply a by b, sorry, b by a. Okay, now let's say the two elements are not multiples of each other, they are not the multiples of each other, so we can find their LCM. Now let's say we have 10 and 3, the same test case which we have. What if I do 3 to this and I'll do 10? I'll need 13 operations. Sorry, I'll do 2 operations only. I'll need the 2 operations only, because I'll multiply this by 3 and multiply this by 10. Okay, so on the LCM of this, basically LCM of what? A and B. Let's say we have this as an integer value in B because the constraints were small. Let's say L is the LCM of this. Okay, so I just want ops plus equal, I can say ops equal to L by A, ops plus equal to L by B. Okay, so we have this as long. I can convert this to int. L by A and L by B. Okay, this should give me the answer. Thirteen zero. Okay, why it is 13? In this case, it would be always 2. It will never be greater than 2, because we have some LCM. Like let's say for 10 and 3 we have 30, which means that we can always multiply this by this and this by this to get 30. Okay, so 2 operations is the maximum that we will get. If this is the case, we will do this. Okay, if both are equal, 0. If one is 1, here it would be simply 2. You don't need to check anything. Okay, both the elements are not 1, which means, and they are not multiples also. Okay, both the elements are not same. Both the elements, if any of the element is 1, then also we have the answer. And this should not be multiples. Okay, I want this case. Like if this first element is multiple of the second element, then it would be still 1. 1 1, it would be still 1, else we have 2. Okay. I can maybe merge these two cases, but let's keep it as it is. Okay. I think we wasted a lot of time in this question. Seconds. Okay. Okay, so the problem here is basically we have an array, and this each element represents an O1 which produces a of I cakes, okay, each second. And there is one lady, Maple, and she wants to maximize the cakes that she can collect, and and at every second she can go to any of the index to get the element. Okay. Okay, so we have 3 4 like 1 2 3. Okay. First cake will collect for at first second. The first will generate only one cake, but every time I'll just go to this last one, then I'll have 12 cakes. Oh, so at every second we are increasing each element by its multiple, and every time we have to just take the one which is maximum. Okay. Okay, so to give you an example, like let's say, okay, let's say we have the cakes as 1 2 and 3, like these are the ovens which can create this much cakes in each second. So every time this will be multiplied, this will be doubled. Okay, so let's say we have this at t1 and we have m equal to 4, so we have 4 seconds to collect the cake. So at t1 we will just collect the maximum here, which is 3. So I have 3, then I have 2 4 0, because these cakes just doubled. Okay, so here again I have 3 because I collected this cake, so it became 0. Now again we have 3, so the maximum here is 4. So we'll just add this 4. So now we have this 4 0 6. So let's collect this 6, and again here it would be 4. Here it would be 4, because in this second the 4 cakes were regenerated. Okay, so here we have 8, and then we have, okay, so here interestingly there will be 2 more cakes which will be added, so it would be 6. So we should not double it, instead we should add the same element to that element. Okay, like we should add 1 every time, so here it would be 3. Let's just take this example again. I think I messed up. So we have m equal to 4, we have 1 2 3. At t1 we will collect this 3, then we will have 2 plus 2 is 4, and again we have this 3, so we will collect 4, so we have 4, this is 1 2, then for the third second it will become 3, so 4 will become 6, and here we, okay, so 4 will be same because we collected this, so 3 will be carried and 3 will be added to this, so it would be 6. So I'll just add now 6 for this third instant, and again this 3 became this 6 became 0, so we again have 3, and this for this 4 we again add 2 to this, so it would be 6 because the oven is producing 2 cakes at this index. So here also we have 4. Now the maximum here is 6, so we will just add this, so it would be 6 plus 6 12 13 14 15 16 17 18 19. Okay, we have 19 here. Did we missed something? We have 1 2 3. Let's collect this 3 will become 0, and again we have 3, 2 will become 4, 1 will become 2. Okay, I add 4 will stay as it is, 2 will get to 3 will get to 6. Maximum here is 6. Collected this, let's go to the end. At the end we again have 6, this became 3, we collected 6. Okay, so this seems correct. Let's check the example. So first we collected 3. Okay, in the first second one collects 1 2 3 cakes. Okay, 0 cakes remain. At the end of the second the ovens contain 2 4 3 cakes. Apple teleports to oven 1 and collects all 2 cakes. Okay, nice. Okay, nice. I'm collecting this cake, like I'm collecting less number of cakes so that 2 will be added to this cakes. I have 166 6 cakes. Collect 9 cakes. Okay. Okay. Interesting problem. So we have 1 2 3. At every second it will get doubled, or it will add up itself, so it would be 2 4 6 multiples. Let's write this multiples. 8 6 46, we have 9 12. Okay, this is something which we have. Now we want to maximize these values. We want to maximize this, so I'll choose something from here, and if I choose something from here, for the next position I'll have the same element from which we started. Okay, and I want to maximize my profit. The constraints are 10⁵ here. Okay, we have n cakes. quite interesting problem. We have this only let's say we have this first row. We will always select the maximum. Okay, so let's say I selected this. Now if I select this will be still 3. So if I have 2 rows, I take this 4 like the maximum among this, and let's further grow. Let's say for every element after m seconds it will become 4, 8, 12. Okay, let's make one element to the extreme end. And for the other elements, let's take this 4. So I'll take this 4 and 4 2 times. No, only one time. I can get this only one time. Okay, 3. Let's take this, 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 this. Then it would be 9. So it would be 3, 4, 3, 9. If we select this pattern, we have 3, 4, 3, 9. If I prepare this arrays, okay, let's say I prepare this and I select maximum among this 3. Now I know that in this previous step for this I know that okay, let's number this first. So for this I know that I selected the same index in the previous row, so the difference between them is 1. So I'll just multiply this the first element by 3 only. So I have this 3 here. For all the elements I know that there are some multiples. Okay, now what if I select a maximum at this? But this will follow a greedy strategy. For every element I have a couple of choices, like I can select that element or I cannot select that element. If I go through m is 10 to the power 8, so I cannot iterate for all these m's. I, although I can iterate through n or n, and for each index, if I iterate for each index, I'll check if I pick this index, then what will be my points. If I pick this index, then what will be my point. So I have something as n into 2 kind of array, like, okay, for each of this element, if I take this, and what is the answer? If I don't take this, then what is the answer? Again, I'll just write this example. Okay, let's say I'm iterating. Okay, let's say I'm iterating, and here let's say I pick this element, then what is my answer? If I pick this element, my answer would be 1. If I don't pick it, answer would be 0. If I pick this, 2, don't pick this, I'll be having 0. Pick this, not pick this. Okay, so I have this kind of states. So if I'll go here for this element, if I pick this, okay, if I pick this, so I have to make a strategy here. Like, if I want to pick this element, I can find the maximum of this, or this guys, this. Okay, so this minus the multiple of this minus, if I'm considering this index, and here I'm seeing that I'm picking this, and I already picked this, so my value would be the difference between this seconds into my current one, which is 1. This is maximum, or this guy is like the maximum among this. This is the case where I'm considering that I picked the previous one, and I'm again trying to pick this one. So don't I need to do this for all these elements? Like, I'll say that I'll pick this, or don't pick this, I'll pick this, or pick this, like any of the previous elements. Okay, so the maximum I will get is, if I pick the initial one with the starting element, then only I'll get the maximum up till here. Okay, that's the max I can get here. If that maximum element is giving me a better answer. Again, let's check our example. This element, the best case is I pick this element, so it would be 2, and here, like, let's consider the last only. So the best case would be I pick this and I get 3. Okay, so here the best would be I take this one and I get 1. Okay, I get 1. Or here I pick this and I get the maximum of 2 and 6. It would be 6 here. Here I am considering that I picked this first element, so I have 1, so the maximum would be 4, and 6, it would be 6. Here I am considering the case where I considered 3 only, because I'm stating that I selected this first initially, so I have the maximum here as 4. Similarly here, if I pick the first element, it would be as it is. Here it would be the maximum would be 3, here the maximum would be 3, again here the maximum would be 2. Okay, if I have this kind of stuff, then again I'll come here and I'm saying that okay, I have 3. Since I picked 1, it would be 2, so the maximum would be 6 and 9. For this I have again 2, so I'll reduce 1 from the 2 from this, so it would be 4. Maximum would be still 9. Here I'll just reduce 3, so it would be 6, and maximum here would be 6. So if I'll come here, then if I see this, like this minus 1, it would be 3, so the maximum would be 12. Here again it would be 12, and for this 12 I'm reducing it to previous 9, so here it would be 8. Okay, here it would be 8. What if I select a maximum among these guys now? It is 6, 9. This will exceed 12. This exceed because I'm saying that I selected here 3, but the factor by which the 3 was increasing was greater than these 2 guys, so I'll end up selecting higher values. Since we selected 3, and 3 we got from here, okay, we got 3 from here, and we know that we have 2 values, and here all these values came from this 3, which means that this will be reduced by 3, it will be 3, so the maximum I will get is 4. Now I selected 4, because 4 came from this. Okay, from this. And I know that this is not reduced. Okay, here 9. Now I selected this 4 which came from 2. 2 became 6. Okay, so here as I already selected 3, so this will be reduced by 3. Okay, so I have something as 3 3 4, or I would say 4 4 4. I selected 4 and I have previously selected 1. Okay, now since I selected 4 here, 4 came from 2, so the maximum from 2 I can get is 2, considering this row. And okay, and here I selected 3 in the initial row. So now I know that I selected an element at initial row, and this came from this guy 3. So I know that it will be reduced. It will be reduced by 3, so it would be 6 6, and here I would have 6, or I can consider 2 or 6, anything basically. So I have this 3, this 6, so I can select this 6. Now I came here, till this time I have not selected 1, so it became 4. Here I have selected 2 at this position, so 2 have became 4. Now again, for this position I have already selected 6 in this position, so now it has again become 3. Okay, is it? Selected 3, selected 4, so 2 has become 4. It was 2, 3 became 6. I selected 6, so it became 3. Still have 4. Can add 4. Let's build on this intuition. I have 1 2 3. Okay, let's say I select 3. Then if I select 3, I know that this will still be 3, this will be 4, this will be 1. Select an element. If I select an element, if I select this element, select this element, I would have take this reduce at 2, this one. Okay, here also if I select this element, I will have 1. If I select this, I will have, okay, here it will be 2. These are 1 0 2 0 3 0. Okay, till this point I have, if I selected this, I selected at this point, then I would have this, then I cannot select this. I can only select this. So maximum in this case would be 4. 3 plus 4. Okay. Now if I go here, since I have selected this, I have selected this. So 6 here, 4 here. Let's go to the end. Selected this, so 3 became 9, 3 became 6, 6 became 9 here, 9 in the last row. Okay, if I have selected 6 here, then I can select only 3 here or 8 here. Or 6 here. Let's select one element and let the guys go. So this will be for each timer. We will have n positions. I'll get memory limit exceeded if I do this. I have this guys, this guys, this guys, and this guys. For every element, I can take it's one piece, two piece, maybe three pieces. If we have a one piece of this would be 12, two piece of this would be 6 and 6, or 3 and 9. Which means we can always take a single piece of this element. Okay, at the end, if we take it two times, I will get this number. At the end it will become 12. At the end it will become 12. At the end it will become 8, and at the end it will become 4. Our choice tag. Let's take this complete thing. So I have some elements left. Two elements are left, which I can take from this two guys. So if I take 2 from this, it will become 8 because I'll take half, then half. Or I can take, let's say, 6 from here and 1 from here. Or I can take 2 from here, let's say 4. Okay, which is one step. And let's take one step from here, it would be 4, which is 8. Okay, which means for this maximum element, let's take the max value when it will reach its max value. Okay, this can be done in one operation or two operations. Let's say we do this in one operation. We're doing this in one operation, we are getting 12. If we are doing this in two operations, it will still be 12. For any number of operations, we will get this constant value. Okay, I can make 12 in one operation. I can make 12 in two operations. Can I make 12 in three operations? It would be one. We have two. This is 6 and 6. Two. Let's say we have three operations. First we'll take 3. It will still be 3. Let's take again 3. We have 6. Then we have this complete 6. Okay, we have 2 operations. We have 3 operations in total, so it will be 12. Okay, so these complete guys can be taken in 1 to m operations. Okay, so for the remaining operations, let's minimize this. Let's say I do this in one operation. Still I have 3 operations remaining. Similarly, I can do this. I can take this 8 in one operation. Let's say I take this 1 in, let's 8 in one operation. So I have 20 now. 12 plus 8, 20. Still I have 2 operations remaining. Okay, for these 2 operations, I waited till here, which means that I have to take something here, take something here, take something here. 1, 2, 3. So I can take 3 here. Okay. Okay, let's say I have 1, 2, 3. I take this one. Again, I have 1, 4, 9, 6. Let's take this one. Okay. Then for this, again I have 1, 6, 9, and okay, interesting. Let's say I have something here as an element 1, or maybe it will be 2, and then it would be 8, 12. So I will take this. I will take this. For the remaining operations, I will have to take this. Okay, I'll take this, and for this remaining operation, I have to take this. Why? Because I'm maximizing my chances of creating greater values. So it would be this, and for all the remaining elements I can take this after sorting the element. So let's check for this 2, 1, 2, 3 and 1, 2, 3. If we have this 1, 2, 3 2 times 1, 2, 3, again I have this. Let's say I have 2, 4, and here it would be 6, 6, 2. 8 is the maximum I can make here. We have 1. Okay, so the proof of this will be I'm taking the maximum, because this is the maximum value. I am sorting the array. Then again I am taking the second maximum. In this way I'm taking these elements, and once I finish taking all the elements, okay, so for this first element, okay, 1, 2, 3, 2, 4, 6, 3, 4, let's take the 6, 9, 12, 8, 4. Okay, I take this, I take this. Now I have just 2 elements remaining, so I'll take this and this. but only one time. Okay, so I was having m elements, three, four. Okay, so for two guys, I just take these elements because I know that this is the maximum, and for the first element I have to take this, which is m minus n minus 1 times I have to do a of this 0 element. I'll take this, and for the remaining, the last element, I'll do m minus 1. I'll do this for the n minus 1 guys. Why? Because I'll take this for all the elements. Okay, I got this, and then at the end I have to take the same element again and again for these guys. Okay, so if I sort the array, have the element. Okay, so I have n and m, and I have the elements. Okay, let's say n equal to r dot next int, we have m, then we have our array as, okay, okay, let's say we have the initial part as, first part as a of, okay, let's check the size of this a can be of size 1. If a is of size 1, okay, if n is of size 1, we will take the element, take the single element all the time. Okay, so the first part would be of 0, let's write this separately. If n equal to 1, then I'll simply say it at out.println a of 0 into m times. I'll do this m time. Okay, else we have the first part as, first part would be m. Okay, we have this complete m minus n minus 1, that is we take all the remaining elements in the cross fashion. Okay, okay, we were having 4, n minus 1 would be 2, because if we do this cross thing, then I can go till here. But what if my n is greater, m is greater than my n? It is fine, but what if my n is greater than m? Let's say m is 2. Okay, then we only take the cross side. Okay, will it make sense? Okay, I think she can wait till we have all the elements created. Yes, she can wait till all the cakes are prepared, which means that which means that okay, this basically means that if only one row when column is present, we can take the element at the end always. Okay, and for this kind of stuff, like okay, for this kind of stuff, if let's say n is, let's say we have 1 2 3 4 5 6 7 8 9, n is 3, m is also 3, we can always take the values in the cross fashion. M is 2, we can always take this cross values. What if we always take the cross values only? 12, 6, it will be 2, and for the remaining we will not take any of the values. So can we just start from the end always? Okay, so if this is the case, then my answer would be simply, if I say that my answer is 0, then we have sorted element in the array. So first I'll take the, like let's say if I iterate on the array, so what I can do is I'll just iterate in the reverse manner. Okay, I'll iterate in the reverse manner, and I'll add my m into my array of this current element, and I'll reduce my m so that I'll get a okay third element. Considering initially m was 4, I'll get 3 into my second highest element. In this way I'll just continue doing this stuff. And if m is less than or equal to 0, I'll just break this guy, and then I can just print the answer. This should work. This will work basically. So I'm always taking the highest element, the second highest element, then the third highest element, till I can go in the cross manner. And for the remaining element, remaining m values, I will not take any element. What? We have wrong answer on pretest 5. Okay. I think we can solve this. Okay. So I have n as 10 to 5 minus 10 to 5. Two raised to kx. Okay. Okay, in one step they can perform easily one of the following two operations. Half for kx to okay. Many number of steps required to reach the target distribution and to output any valid sequence of operations achieving the minimum. At most 20. Okay. Great, we did a silly mistake here. Okay, so we have solved two questions. Wasted a lot of time here. Okay, let's check our standings. 9,000. Okay, if we are able to solve this third question, then we would be getting a decent rank, at least around 6 or 7,000. Okay, let's first focus on this. Okay, initially we have 2 raised to k plus 1 k. This a gets, let's say we have a and b. A gets 2 raised to k cakes, and then the other guy gets 2 raised to k cakes. Okay, and then we want to distribute the cake such that, like, okay, this a should be that the number of cakes that a has should be x at the end, and here it should be 2k plus 1 minus x. Yeah, it should be 2 raised to k plus 1 minus x cakes. We have to do this. We have to distribute the cakes among this. Okay, the only condition is if a is having even number of cakes, then a can give half the cakes to b, and same for b. If b is having even number of cakes, she can give half the cakes to this. Okay, that is, we can reduce a number by half and increase the other number by the same amount. Okay, minimum number of steps required to reach the target distribution. Okay, we have the test cases. Then the first line of each test case contain two integers k and x. First line of each test case contains two integers k and x. Okay, we have k and x. 2 raised to k plus 1. X is between these two guys. Integers. The ith step is half. Okay. Okay, great. We have 2 and 3. So we have k equal to 2, x equal to 3. So we have the total number of cakes as 2 raised to 2, which is 4 cakes. A is having 4 cakes, B is having 4 cakes, and we want one of them to have, like, A should have 3 cakes. So first, let's say A gives all the half of the cakes to B. So we have A equal to 2, B equal to 6. Okay, now still we have an even number. Let's give half of the cakes to this. It would be 7. This both became even, so none of them can give cake to anyone. So this is invalid case. Now let's say that A equal to 2 and this gave half cakes to this. So we have 2 plus 3, which is 5, and for B we have 3. Okay, we have 5 here and 3 there. So both became odd now. Still we didn't get our answer, so this is also an invalid case. Now let's try the other way. Like initially we were having 4 4 for all these guys. Okay, so if one of these guys is getting our answer, which means that the other guy will definitely get the answer if we perform the same operation in reverse order. Like what we did is we first gave cakes from A to B, and then we just continued the process. Instead, what I'll do is I'll start from B, and B will give half of the cakes to A. So here it would be A equal to 6 and B would be 3. A would be 6, B would be, sorry, B would be 2. Okay, B would be 2. If I give again one cake from here to here, I'll have both the odd numbers. So A will give the cake to this. So now I have A equal to 3 and B would be simply 5. Okay, so we have to check if okay, so the answer will always be available. The answer will always be available. We just have to check how can we make this. Okay, so for the element 4 and 4, if I make the half of it I have 2. If I make the half of it, I have 1. So I can reach in log n operations to 1. Okay, here also I will reach in log n operations, log of 4 operations to 1. And whenever I will reach this case, I will have an odd number. Okay, so if I want to make one odd number here, like if our m is odd, what is this, m or x? Yeah, if our x is odd, then for this 4 and 4 I'll make this 2, then I'll make this 1. Okay, first I make this 2. I'll add 2 here, 6. I made this 1 again. Again I'll add this to this, so I get okay, 11 here. But if I recursively try to do this, so I will go from 2k to 1 in log of 2k. And what is k is I think 60. Yeah, okay. I think it is doable. 4 4. I want to make an odd number. If I want to make an odd number, I'll have to add one odd digit to this even digit. Okay, 2 6. Okay, if a number becomes multiple of 3, number becomes multiple of 3, I can make the other number odd, but this will make the same number odd. It is 4. I go to 2. From 4 I go to 2. Then here for 4, I'll just add 2 here. It would be 6. Now again, this guys will be half. Okay, so it would be half. I get 3. I'll add this 3. I'll get 5. Okay, we can make an odd number by adding 1, or adding a multiple of 3, or adding a multiple of any odd number. So every time what I'm doing is I'm adding half of it to other number and reducing this by half. So my other number can go up till 2k plus 2k plus half of log n times I will add. Okay, okay, so I want to make x. Okay, if I have an odd number, this is Okay, this case is clear that if the number 2 raised to k is m, then we have 0 operations. Let's write this extreme base case. Okay, we have n and x. We know that if of 2 raised to have x, okay, we have 2 raised to x, what do we want here? This is equal, okay, so if 2 raised to k equal to x, then we have our answer as 0. Then we can simply return from here. Okay, if this is the case, then we can simply return from here. What else do we have? Now we definitely have some answer. Now we definitely have some answer. Let's say we have this 3 and 7. 2 raised to 3, and we have this as, let's say we have this initial n value, and we have x equal to 7. So we have 2 raised to 3, which is 8, and we have this 7. We want this 7. Let's keep the half of this. So we have two values, 8 and 8. Let's do the half of this. It would be 12, it would be 4. Okay, 12 and 4. Let's give the half of this to this. It would be 14, and we have here as 2. 1 operation, 2 operation. Let's give the half of this to this. So we have 7 here, which is our answer, and here it would be 9. So after some point, both will have odd values. After some point, both will have odd values. What if we have something as some even value? Let's say we have 8, x equal to 8, and k equal to 2. So we have 4 initially with the guys, and I'll add half of this to this, so it would be 6, and here I will get 2. Okay, I'll again add half of this to this, 7, and then I'll get 1. Odd, but I cannot make the element now. Just to this 4. Okay, one into 2 is 4, 7. 1 into 2, 1, 2. Then we have 4, then we cannot double it, so we have this 3, which we can add to 4. Okay, so the maximum element which I can make is, I'll add, like we have for 4, we have 4, 2, 1, right? I'll just double this. If double this, if after doubling this, this is not my 2 raised to k, then yes, I can perform this. Let's add 1. After doubling this, I have this 2 raised to k. So this is my last operation. Okay. Okay, so I'll keep on doubling till till the current element is not 2 raised to k. So this is the number of elements which I'll get, or the total summation which I'll get, which I can add to my single element for. So I'll get some element which I can make. This is the maximum element which I can make, because I initially kept the highest possible value which I was initially having, and then I just keep on doing half for all the element, all the times for the other element, and I just added this. Okay, do we have to output -1, because this is definitely the necessary condition that we should have. Okay, so this is the maximum element we can make. Okay. I cannot make this, but what if I have 6? This I can make, but how? For making this, initially 2 raised to k equal to 4. For this 4, let's give some number to this. So it would be 2, and here it would be 6. Let's again give a number to. Okay, I got this element. If this is an even element, I'm just adding half every time. Let's see again, if we have 6 here and 6 here, 6 here, and let's say I cannot have 6 here. I have, let's say, 8 here and maybe 12 here. Okay, can add half of this to this. It is an even number. I'll keep on adding the half of this to this number. So I'll get 4. I'll make this. If I again keep on adding half, I'll have 2, 14. If I again keep on adding half, then I can make odd number. But what if I want to make 10? Is it possible? I have again 8. So for this 8, I can always add 4 to this. Okay, if I am adding half of this element, this crosses 10. Either ways, if I go half from here, it still crosses 10. Okay, so the elements which I can make is, if I have this as, let's say 2 raised to k is some element, let's say n, and I have some x is, let's say x is some element, then 2 raised to k by 2, 2 raised to k plus 2 raised to k by 2, this is the lower bound which I can make. And what is the maximum I can make? I'll just keep on doubling the elements, and till it is not 2 raised to k, and that is the upper bound I can make, that is 2k plus this result, 2 raised to k plus this result is the upper bound I can make. Now I think that we can always make this, that the constraints are provided such that we can always end up making the element. So let's not bother about this upper bound, let's calculate it at the end. Like, this is a kind of safety check that we are adding. But now we know the lower bound. Now another thing is, if it is an even number, then I can make this by adding first 2 raised to k by 2, then I'll add 2 raised to k by 2 again, then I'll add 2 raised to k by 2 again, like the result of this by 2. Okay, the result of this by 2. Okay, if I keep on adding this, then I'll get some even numbers initially, then I'll get an odd number at the end. Okay, this can be made by giving one element from the other to the other. Okay, like if let's say our a is greater than 2 raised to k, then b will always provide elements to a. Okay, this is one thing. But let's say if, okay, if at any point a becomes 14, I have x as 7, then I'll do the half of this. But in this case x is odd, so if x has to be even, then okay, I'm stating that if a is greater than what, 2 raised to k, is greater than 2 raised to k, then this should provide the elements to this. This should provide the elements to this. Okay, this is for sure. And here also, if it is even, then we can make in some operations. If it is odd, okay, let's say 2 raised to, let's check the example, and if we can see any example which matches our condition. I have a as 2 raised to k, a will never be, sorry, here we want x. If x is greater than 2 raised to k, then we have this. So 2 raised to k here is okay. If we have x is 2 raised to x is greater than 2 raised to k, then I can always make it by providing values from b to a and check if I can make this. Okay, so one observation is if x is greater than 2 raised to k, provide and okay, and x is even, provide elements from b to a. Okay, if x is odd, then we can provide elements from b to a, provide from b to a, else at one point at any point, if we check if x by 2 or our current, I'll check if our current summation by 2 equal to x, we have our answer. What if x is less than 2 raised to k? So this is definitely true because x is even, provide element to this. Okay, what if x is odd? If x is odd, we have provided elements from b to a, because this will eventually end up having 1 or 3 or basically any odd number, and if we add that odd number to the other number, we can check if we get our answer. Okay, and the other thing is, if we are adding elements to our one element, then basically we will get some number, like some number, and if the half of it is our x, then this is our answer. But this is the condition when x is greater than 2 raised to k. What if x is less than 2 raised to k? We have if x is less than 2 raised to k. Let's check this test case. We have x as 4. Okay, we only checked for the when, yeah, we have this odd condition also. Okay, let's check this case or this case, 2 raised to 5. So here we have 2 raised to k is 2 raised to 2 is 4, and we have x is equal to 5 and x is greater than k. So is x even? No, x is odd. Okay, so provide all the elements from b to a. If we provide all the elements from b to a, then it would be, we have 4 and 4. Let's give the half to this, it would be 6. We have to again, let's give this half to this 1. We have 7. We have 7. So do we have this? No, we don't have this. Okay, then another thing is, okay, we did this. Okay, this is not possible, I think. Two and 5. Okay, 1 and 2. So we have 4 and 4. First fill this due to this 6. We have 2. Okay, we give the half of this to this. Okay, so provide bitway, and this should become our x. Like, let's say this should become our x, or half it should be x, or our current by 2 if we give to a should become answer, because after this we cannot further divide because both of them became now are odd elements or maybe even elements too. Instead here if we have 4 or we have 2 6, or let's say we have 8 then for this 8 I'll give this 4 12, again I'll give this 2 14, have this 2, I can give half to this. 14 to 2, 2. Check for this example again. What was the example? We were having 1 and 2 and 5, so it was something like 4 and 5. Okay, this was basically 2 raised to k, and this was x, and I'm having 4 and 4. Let's first write if we give one element to other element. So if we give this to this to this, we have, let's only consider one case for the first time. We have 4, we have we have 2 and 6. Okay, let's start building from here. If I give this 2 to this, like the half of this to this, I'll get 7 and the other element would be 1, or I would say 1 and 7. we give half of this to this, I'll get 3 and 5. Okay, now these two guys are odd, then I cannot give it to any other element, and I got my answer. Okay, let's check another case. We have 2 and 3, so we have let's say n equal to 2 and x equal to 3. We have, this is k basically, 2 raised to k is equal to 4, and now we have x equal to 3 and we have to make x, so we have 4 again. Now we initially do only one step, as we have this two same numbers, we will end up with the same values if we do the cross of this. So let's take, we have 2 and we give half of this to this, so we have 6. Great, we have 2 and 6. Let's say I give half of this to this, I have, this became 1 now, half of this would be 1 plus 6 would be 7. Similarly here it became 3 and half of this would be basically 3 plus 2, which is 5. I can make this, guys, and what I want is for 2 and I wanted 3. Yeah, so I made it. Now let's check for an even number, or let's check for this 3 and 7. So we have 2 raised to k is equal to 2 to the 4, 4 to the 8. As our k was 3, x was 7, I think. Yeah, so x was 7. So now we have 2 raised to k equal to 8. 8. So if we give half of one element to other element, it would be 4, and we have 12. Great, now let's build on this. So if we give half of this to this, we have 2 and 14. Similarly here it would be 6, and we gave half of this to this, it would be 6 plus 4, which is 10. Okay, again let's build on this. We have half of this. Okay, again let's do the cross. Half of this is 3 and we have 3 plus 10, which is 13. I can make 13 here, or I can make 5 and 5 plus 6, 11. Okay, if I do the crisscross of this, I can make 1 and 15, or I can make half of this would be 7 and 7 plus 2, which is 9. Okay, great. At the end I'll always get odd numbers, and if at any point I get my answer, then yeah, we will just return this. So we do this operation log of 2 raised to k times. We keep on doing this every time, and I'm checking if these two values are there, and these two values can range. These two values can range up to 2 raised to k times. I think recursion will pass here. And I just want the path which led to a particular number. Okay, so this is the classic backtracking, I think. So let's say I have some DFS method. Okay, I have a I have p, okay, long x. Let's say I have some number x. I have my list here. Okay, I have this list here. I have a, b, and x. Okay, now what I want to check is if a equal to my x or b equal to my x, return, like don't remove anything, return. Let's return to here. Okay, if one number is odd, it means that other number is also odd. If a not equal to 0, this is an odd number, I'll just straight away return false from here. Just straight away return false from here, because we know that this a is not our x, so we cannot break it further. Okay, else what we have is we have two things. That is, let's provide half from first element to the other element. Okay, so it will be DFS of a plus a b by 2. Okay, we give the half of the b to a, and we still have our b now, but we have half of b, and we have our x as it is, we have ls as it is, because we will do the operations on ls. Prior to this, we do ls dot add. What we add is we add here 2, because b is giving its element to a. Okay, so we add 2 here. If this returns, if this returns true, I'll just return true from here. Else what I'll do is ls dot remove ls dot size -1. I'll just remove the last element which was added. Okay, then what I'll do is I'll check if we can make our x, if we add from a to the other element. We here have by 2, we have a by 2, b plus a by 2, we have our same, guys. Okay, false. If b is giving to a, we have 2, a is giving to b, we have 1. 1 means that half of keys to vanilla. Okay, 1 is giving, 2 is giving, we have 2 is giving, and 1 is giving. Okay, so we have our DFS function ready, and this should work. So we have DFS, okay, so it should be a static function. We have DFS, and then we have a. What is our a? A is basically named as 2 raised to k. Okay, it would be of 2 raised to k. Let's say one number is half 2 raised to k by 2, and we have, let's calculate the power separately here. we have, what is the problem here? Okay, we have power by 2 and we have 2 raised to k plus 2 raised to k plus power by 2. 2 raised to k is power, so we have power plus power by 2. And then we have our value x as it is, and we have new array list. Print in our list. Okay, so here I need to declare our list. Print simply here as, yeah. So yeah, this should give me the answer. Two zero 2 and 2. Okay, something is missing. Yeah, something is missing. I didn't write the minimum number of operations. I want the minimum number of operations. Okay, I want the minimum number of operations now. If this is true, I can keep track of the minimum. Let's say I have some global minimum here as I have a global minimum here, and if it should be max value. Now if we have our minimum greater than ls dot size, it is greater than our size. If it is less than our size, then we can include this our minimum. Let's also keep track of a global list. Oh gee, okay, so in this case this would be ls. Okay, if this is the minimum, I can just return true here, and if it is not the minimum, I can continue, and when I'm continuing, if it is an odd element, it will anyways return false, and if it is not an odd element, I'll check by dividing it. This way I'm trying to make the minimum element. So here I can just do out dot println of my mini. Here it would be G. Else is null. Okay. I'm getting maximum value. Mini is never less than. Mini is greater than or ls dot size. We are adding our new minimum. Why do we have that? Print G. Two, two, 1 0 1 1. I'll just write here. Here I have ls. Have ls dot size. What was the issue in this code? Let's try to figure it out. 8000 solved. One zero two one. Two operations. Why we save one operation? We are converting 2 to 3. People to. Let's try to quickly debug this. Okay, we have 2 and 6. Perfect. 2 is not an odd number. Okay. Let's add 2 first. Okay. First 6. I add 3. So B became 3 because we gave 3 to this. Okay, now it is 2 because we have 3. Okay, I forgot to add first step. forgot to add first step. It can be any step, like the first step can be any step. I can just add ls to ls dot add. Oh, okay. Okay, the first step can't be any step, but instead if our b reaches our target, then we have the first step as for b reaches our target. Okay, I'll have to provide this with the values. I have to provide this p and p so that my answer will be calculated based on this. Now I want to calculate the minimum. 2 Now I should get the correct answer, but let's check how we can calculate the minimum. 2 is 2103 Here I'm saving 21. Okay. If our A reaches the target, then okay, I'll maintain a variable is equal to, let's say, reverse is equal to false. Let's say we have reverse is equal to false. Okay, now if our B reaches our target, like if B is equal to X, then we know that B reached the X, but instead we wanted our A to reach X, which means that we have to do the reverse of this exact operations. Okay, now if we have reverse, okay, let's if this reverse, then what I'll do is I'll maintain an array of the same length of this ls. So this will be basically let's say this is equal to new int of ls dot size. Okay, I have this ls dot size, and from this what I'll do is from this I'll just add for each of this element ls dot size I plus plus if ls dot get I, if this I equal to 1, okay, then raise of I would be 2, this raise of I would be 1. That is, I'm making the reverse of this so that at the end I can just print my array. I'll just print arr race, and here it would be the size. Okay, I'll just print the size, and I'll just print the elements here and return. So instead of this, I'll just out dot print my if ls dot get I equal to 1, I'm printing 2, else I'm printing 1. Okay, at the end I'll just give a space here. Okay, now if this is not the case, then I'll just print this in both cases, and at the end I'll just do ls dot, or I can say in my ls I'll just print it. Okay, So this will give me my answer. I am concerned about the minimum stuff. Why it is not printed correctly? Okay, so here it should be n. Here it should be n. We have 2 2 1 0 2 2 1 0 3 2 2 1 0 3 2 2 1 2 1 2 2 and 1 2 2 and 1 2. Because here I want it to have. Okay, now this is correct. Now let's keep track of the minimum size. Okay, let's keep track of the minimum size. So at the end we got some answer. Okay, so we have some answer. Then we have some answer. What we can do is we can just take this answer and we say that still we didn't got any answer. Let the process continue. Like if I just uncomment this, here what I'll say is I'll say if my minimum was greater than this, this is my minimum, but I'll not return here. I'm not returning from here. I'm not returning, and I'll keep on doing the same process again. So here I can say after this my ls equal to, let's say, g. We have 2 1. For this case we have 2 1. For the third case 1 2 3 3 and 7 we have 2 1. So if we do 2 1 we have 3 and 7, which is 8 and 7, 8 and 8. We do 2. What is 2? This gives half to this. 8 half to this 4, which is equal to 12, and again we have here as 4. Now we have 1. 6 by 2 is 6. 4, which is 10, which is not equal to 7. What if I just keep track of all the elements? Okay, I got some value. Okay, I got some value. Can I again do half of this? This will increase my value. If once I got a value, like let's say for two numbers 4, and let's see here it is something as 6. I got a value here as 4. Then if I again reduce this and give half of this to this, will it make sense? Like 4 4, I have 2 and 6. I am giving half of this to this. I know that I have 2 as my x. Is there any point in continuing this from this point? Is there any point in continuing this from this point? Anyways, I'll get a minimum value because I'm extending from the highest values. So let's try to submit this. I hope we don't get TLE, and also about the part where we have to find a minimum. I'm not sure about that. Okay, so we will not get the minimum every time. What if we add everything in the list and just sort the elements by their size and just take the first one? Let's try this too. See, we have a global list of list. Okay, why we have 3 here? Okay, I want a minimum. So I'll add some of this on the 0th position.